Government's pledged to build 6,000 new homes on this year's defence land.
Ecologists and horticulturalists have found that we have less than 60 years left of viable topsoil. Melbourne's population is rapidly increasing at a rate of over 1.5% each year, requiring more resources than ever before. Developers have begun building on known contaminated brownfield sites for an immediate paycheck, while major infrastructure projects dump toxic soil to the backlash of concerned residents. We are stuck in the same mindset: more building, more housing development, more pollution, more congestion. But let's stop for a second. Sitting on the outskirts of inner Melbourne, no site has been more contentious than the Maribyrnong Defence Site. Abandoned and neglected, it has been left empty for the last 25 years following an extensive 85-year tenure of chemical and weaponry manufacture. A site filled with historical significance, but also widespread contamination. Benzene, TNT, asbestos and mercury are just some of the dangerous and toxic chemicals that have seeped into the soil. Many are classified as carcinogens. Developers have come and gone, overwhelmed with the arduous task and enormous cost of traditional decontamination methods required. So, is there an alternative? My name is Andrew Sicilia, and this is Operation Decontamination. Operation Decontamination opts to take a new approach and asks, how can a staged approach to the repair of the environmentally degraded landscape of the Maribyrnong Defence Site lead to the development of a more ecological and socially sustainable suburb? The project engages with the method of phytoremediation. A new technology utilised in projects such as the Delprat Gardens is revolutionising the way we deal with contaminated soils in a clean and safe way, while also costing less and reducing the overall carbon impact. Plants known as hyperaccumulators can accumulate various toxins, heavy metals, and contaminants out of the soil. One of the main methods is phytoextraction, where plants uptake contaminants and store it in their leaves. We can apply this method to clean up the soil without resorting to costly traditional methods, such as covering contaminated areas with concrete or carting toxic soil off-site. Historically, the Maribyrnong Defence Site was a testing ground for chemicals during its peak. Today, it can become a different type of testing ground, one used for decontamination and regeneration research. The benefit of the site is that time is on our side, as some of the chemicals may have already broken down through the process of chemical half-lives, and there may already be hyperaccumulator plants on site working to remediate the soil. Fires that are swept through the site may also have had the same effect. The project is broken up into two main phases: decontamination and restoration. Let's begin with Phase 1. Phase 1 begins the process of decontaminating the site. I've divided the site into 4 main areas, which represent how potentially severe the toxicity of the soil is and the cleanup engagement required. Starting with the most toxic red zone, which covers most of the site, the orange zone, the yellow zone, and finally the least toxic green zone. Prior to any work on site, a series of tests to determine the contamination are undertaken. Trees on site are assessed for their hyperaccumulator value, as some of them may already be decontaminating the soil. We want to know what is in the soil, where it is located, and the toxicity levels. In response to the testing, a unique set of hyperaccumulators are planted in each area which target the contaminants. Once the plants have reached their maximum accumulation potential, they are removed from the ground and sent to be incinerated to ensure the chemicals don't leach back into the soil. The process is repeated for as many times as required to reduce the toxicity in the soil to a safer level. The length of this phase is determined by the accumulation performance of the plants. A new incinerator will be built on site to facilitate this process, incinerating plants and using the burning process to produce energy for the local electricity grid. In Phase 2, however, the incinerator also supports the recycling of material. The potential for what we can do with the various hyperaccumulated plant groups as landscape architects is vast and fascinating. Beyond this project, phytoremediation can become a valuable resource for application in new developments and projects where contamination may be present. Once we know that the site has been remediated to a safer level, we can begin to introduce garden experiences for local communities to immerse themselves and learn about the potential of hyperaccumulators, which they can successfully use in their own backyard. Designed remediation areas, including a new wetland, demonstrate the variety of uses of hyperaccumulator plants and the practicality of how they can be used for habitat, teaching, and well-being. Wall gardens filled with hyperaccumulators shield users from areas still requiring remediation. These gardens offer users a viewing experience into how the process works and functions. Community engagement and involvement is one of the most important components to ensure the success of this project, and Phase 2 is built around designing experiences. We want to inspire users to get involved in learning about ecological sustainability through the principles of regenerative soil along with phytoremediation practices. After the process of decontamination, the soil may require balancing in mineral content and topsoil microbiomes. Further soil tests are undertaken to see where there are mineral deficiencies. In these areas, composting and mulch practices are brought in to assist in regenerating and enriching the mineral content of the soil. A new education precinct is one of the new installations on site, fostering a space for learning and engagement about the importance of regenerative soils and soil health. Local school students are invited to participate and learn about the basics of sustainable practices in an organic and fun environment. New expansive garden beds facilitate easy communication and demonstration of the phytoremediation process and soil health. Education programs can be extended to locals to further community awareness and get them invested in their future and future generations. The incinerator takes on a new role in Phase 2, maintaining its position as the main hub for incineration of material, while also offering areas for compost production and mulching. A new waste management system will be implemented, which takes food waste and other rubbish produced by locals and businesses on the site and recycles it for reuse. A major design element in this project is the Market Hall Square and Gardens, which is located in the heart of the Maribyrnong Defence Site. This square is designed with organic paving pattern, which features a variety of plaques embedded into the pavement, detailing the contaminants produced on site. A new production garden works in conjunction with the Market Hall to create a unique community hub founded on the principles of food production and sharing. Locals can volunteer, learn, grow food and sell their produce within the Market Hall. Programs are designed to encourage locals to engage with their gardens more and in the process reconnect with their community. Community input has highlighted the disconnect in the Maribyrnong River Trail. A new pathway system will be installed, connecting people to the existing river trail, and it extends around the site. The outcome will achieve improvement in people's mental health and general physical well-being. The heritage-listed buildings of the site will be restored and refurbished as classrooms, museums, cafes and businesses. Preserving the First Nations story of the Marrinbullock people and their connection to this land can be facilitated through designed moments. We want to tell the stories of the many workers of the explosives factory while paying tribute to Sandy the Warhorse at the repurposed Remount Stables. Many MPs and government agencies have called for the site to be decontaminated and redeveloped into high-density residential housing. However, to do this, we miss a great opportunity and ignore issues of soil degradation and erosion. This wedge of land has been untouched and is full of historically rich and diverse stories that should be shared and preserved. This landscape presents itself as an opportunity for research into new, innovative landscape solutions, observing it like a landscape petri dish to see how we are going to solve modern ecological problems for today and for tomorrow. We aim to create a thriving and exciting new suburb type built on the ecological sustainable practices. Landscape architects should be embracing these concepts, and Operation Decontamination can be the catalyst to inspire and push our involvement in remediation. The old solutions are costly, ecologically damaging, and place the problem in someone else's backyard. So, do we dare to take the next step forward?